Incidentally, grandiose occasions of amazing scale happen billions of kilometers away from Earth, resounding all through the universe. And presently, a comparable event is approaching, starting wonder even among researchers. A red monster star, arranged at the outer ranges of our galaxy, is communicating foreboding signs across the universe, caught by the James Webb Space Telescope. Cosmologists have uncovered deeply disrupting disclosures about this titanic heavenly body. As recognized astrophysicist Brian Cox gives a grave admonition, a pressing question emerges: are we wavering on the verge of seeing a calamitous cosmic explosion, a blast that could permanently modify the natural night sky? Prior to digging into further details, make sure to subscribe to our channel if you haven't already. Now, the burning question waits: will this blast influence Earth, and will it be noticeable from our planet? Stay tuned as we explore the answers to these compelling questions in this video. In the tremendous spread of the universe, where the show of heavenly birth, life, and death unfurls in entrancing wonder, one specific star has recently directed the attention and concern of both cosmologists and the general public. This star, known as Betelgeuse, stands out noticeably as a red supergiant in the constellation Orion, flaunting tremendous size and age. While its striking ruddy tint and fluctuating brilliance have long intrigued onlookers, recent events have further heightened interest in this heavenly behemoth. As we dig into the essence of Betelgeuse, we find ourselves near the very edge of a potentially stupendous event in the star's life cycle. But what do these changes in Betelgeuse's behavior mean? Might we at some point witness the start of an uncommon infinite scene of unfathomable size? Betelgeuse, flaunting a size roughly 1,000 times greater than our Sun, remains a true epic monster among stars. Its sheer size extends the limits of human imagination. Picture a star so huge that if it were to take the Sun's place, its surface would expand past Mars' orbit, wrapping Mercury, Venus, Earth, and Mars inside its heavenly handle. This phenomenal size not only highlights Betelgeuse's physical hugeness but also its place in the heavenly life cycle. As a red supergiant, Betelgeuse is in the dusk period of its existence, marked by expansion and cooling after a lifetime of fusing hydrogen into helium at its core. Questions emerge about Betelgeuse's age. Despite being relatively young in human terms, estimated at around 8.5 to 8.8 million years old, it remains ancient within the context of stellar life expectancies. Its current status as a red supergiant represents the culmination of millions of years of stellar evolution, characterized by significant changes from a hot blue star to the grand red giant we observe today. The journey of stars like Betelgeuse unfolds as a story of constant transformation, powered by the unyielding forces of nuclear fusion and gravity. One remarkable feature of Betelgeuse's current phase is its striking ruddy hue. This deep red color arises from its relatively cooler surface temperature, a contrast to stars like our Sun. While our Sun burns at around 5,500 Kelvin, Betelgeuse's surface is cooler, clocking in at about 3,500 Kelvin. This cooler temperature allows Betelgeuse to emit light with frequencies painted in shades of red. However, this hue isn't merely a cosmetic trait, it offers insights into the star's physical state and the ongoing processes within its vast gaseous domain. Adding to the interest surrounding Betelgeuse is its intriguing color history. Ancient records from Roman and Chinese sources suggest that, about 2,000 years ago, Betelgeuse appeared yellow. It wasn't until the 9th century that Arabic astronomers described it as red. This historical change in color isn't just a footnote in astronomical records, it serves as a clue to the star's evolutionary journey. The fluctuating brightness of Betelgeuse adds another layer of intrigue. It acts as a semi-regular variable star, meaning its luminosity undergoes periodic changes. This dance of brightness has captivated astronomers and stargazers for centuries. Typically, Betelgeuse follows a 420-day cycle, accompanied by a longer 5.9-year cycle, recorded as far back as 1836 by Sir John Herschel and possibly even earlier in indigenous oral traditions. But what truly sets Betelgeuse apart isn't just its oscillating brilliance, it's its unpredictability. Unlike many stars that adhere to predictable patterns, Betelgeuse occasionally veers off course from its usual dimming and brightening rhythm. This anomaly hints at the complex and less understood processes unfolding within its massive structure. Recent dramatic revelations have captivated cosmologists and skywatchers worldwide. When Betelgeuse underwent a surprising and dramatic change, now widely known as the Great Dimming, it made headlines. It all began in late 2019 when Betelgeuse, the red supergiant shining brightly in the night sky and a prominent part of the Orion constellation, started to undergo a mysterious dimming. The fading was so striking that it lost luminosity at an average rate of 0.01 magnitudes per day, reaching its lowest brightness by February 2020. Betelgeuse, normally visible to the naked eye even in light-polluted skies, became hard to spot. In fact, even amateur astronomers couldn't miss it. However, there's a critical challenge in observing Betelgeuse's activities. When we observe a star like Betelgeuse, we're not seeing its present state but rather its past. Given that light takes time to travel, and Betelgeuse is located about 725 light-years away, the light we see today left the star nearly 7 centuries ago. This time delay complicates efforts to predict and track sudden changes in a star's behavior, since we're essentially observing events that occurred long ago. The dimming of Betelgeuse serves as a clear sign of the inherent complexities of ongoing cosmic observations and the limitations of our understanding. It underscores the challenges of studying such vast cosmic objects, especially when dealing with the enormous scales of the universe and the time lags they entail. The fascinating saga of Betelgeuse's grand performance was carefully tracked by Andrea Dupree, the Associate Director of the Center for Astrophysics at Harvard and Smithsonian, along with her team, using the Hubble Space Telescope. The telescope they left on a 3-year examination to screen variances in Betelgeuse's external air. These perceptions gave an unmatched comprehension of how a variable star like Betelgeuse works with its standard developments and constrictions, prompting vacillations in splendor. The momentous responsiveness of Hubble to bright light empowered the analysts to dig into the layers above Betelgeuse's surface, which were somewhat warmed by the star's fierce convection cells. Moreover, an itemized investigation of the Hubble spectra, obtained at different stretches throughout 2019 and 2020, worked with the estimation of material development inside Betelgeuse's external air. Specifically, the examination zeroed in on the magnesium-2 lines inside the spectra, which offer bits of knowledge into the air conditions of the star. These perceptions disclosed material going at paces of around 200,000 miles per hour from Betelgeuse's surface to its external environment. This warmed and thick substance ultimately extended millions of miles from creepy crawly Jew, filling in as the forerunner to the residue cloud liable for the star's diminishing. Furthermore, her team assessed that during the 3-month explosion, roughly 2 times the standard amount of material from Betelgeuse's southern side of the equator was shed. This significant loss of mass holds importance, especially considering that, like all stars, Betelgeuse ceaselessly sheds mass, yet at a rate much higher than that of our Sun. The greatness of this mass discharge and the resulting diminishing provoked discussions among cosmologists with respect to whether this event could hint at a cosmic explosion. The nearness of Betelgeuse, situated roughly 725 light-years from Earth, adds to the interest. If such a blast were to happen, it would be apparent from Earth, presenting an intriguing opportunity to closely observe a cosmic explosion. Anyway, the question persists: what suggestions does this diminishing event hold for Betelgeuse's future? Does it signal an impending cosmic explosion, or is it only a particular section in the star's broad and multifaceted journey? Different speculations were proposed to shed light on this peculiarity. This sudden shift provoked a few winning speculations. One proposed it as a stage in the cosmic explosion blast process, acquiring energy due to the boundless conviction that Betelgeuse is approaching the perfection of its life cycle. Another broadly accepted hypothesis embroiled dust, possibly originating from the star itself, darkening our perspective on Betelgeuse. A third explanation examined modifications in the star's photosphere, its apparent surface layer, which could affect its visible splendor. Complete investigation utilizing different observational procedures added to unwinding this conundrum. Spectroscopic assessments showed a decrease in Betelgeuse's effective temperature, indicating the probability of a significant dark spot on the star's surface. This speculation found support in perceptions revealing a temperature decrease of at least 170 Kelvin during the diminishing time frame, highlighting significant surface changes. Ultimately, the way to completing this exceptional peculiarity originated from humankind's careful attention in space, the Hubble Space Telescope. Hubble's fastidious perceptions uncovered that Betelgeuse's diminishing likely came about from a significant removal of warmed material into space. This material coalesced to form a residue cloud, darkening a portion of the star's surface and reducing the amount of light reaching us from creepy-crawly Jew. The beginning of the residue cloud was ascribed to superheated plasma, which emitted from a sizable convection cell on the star's surface and crossed through its searing environment to the cooler external layers. After cooling, this plasma resulted in dust particles, which coalesced in a cloud that blocked light from roughly a fourth of the star's surface. Hubble's ultraviolet spectroscopic perceptions, beginning in January 2019, played a crucial role in remaking the course of events leading up to Scarab-Juice darkening. These perceptions identified signs of thick, heated material navigating through the star's atmosphere in the months preceding the diminishing event. By December 2019, different ground-based telescopes also noticed the star's decreasing brilliance, especially in its southern side of the equator. At first, this material appeared brighter than the star's usual glow, ultimately culminating in the formation of a foreboding shadow as it scattered outward. Moreover, this outward progression of material and the resulting foreboding shadow were responsible for the abrupt darkening of the star. The magnitude of this launch is truly stunning, pushing creepy-crawly Juice into the cosmic spotlight. The star removed and assessed 400 billion times the mass normally released in a standard coronal mass ejection. This removed material, believed to offset our moon several times over, marked a significant event, not just for Scarab Squeeze but also for advancing our understanding of celestial mechanics. But what are the ramifications of such a massive discharge of material for creepy-crawly Juice and the broader theories of supernovae? The repercussions run deep. The standard way of thinking proposes that red supergiants like Betelgeuse consistently shed mass before reaching the dangerous summit of their life cycle. However, the scale of this launch challenges this idea.